Okay, this is the Algebra 2 Unit 4 practice test. So number 1 says, what is the positive solution to the given equation? Remember that a solution is an x-intercept. So I'm going to come here and I'm going to graph that using x's instead of z's. So it's going to be x squared minus 2x minus 35 equals 0. Now we have two solutions. It wants the positive one, so our solution would just be z equals 7. Number 2, we need to factor the expression. So the biggest number that I can divide 8 and 16 by would be 8. They can both afford 3 x's, so x cubed, and they can both afford y to the third. So what's left over when I divide both of those by 8x cubed, y cubed would be 1x to the 6th for my first term. And for the second term, we would get plus 2, and that would be it. So my answer would be C. Number 3, it says the x-intercept of the graph shown is x comma 0. What is the value of 2x? Well, my x-intercept would be 2, 0. Therefore, I know that x is just 2. So if I'm finding 2x, I'm really finding 2 times 2, which would be 4. Number 4, they want to know the maximum point. So again, I'm just going to graph it. Instead of g of x, I'm just going to use y. So it'll be y equals negative x squared plus 55. And I'll zoom out. My maximum point is 0, 55. Number 5 wants to know what is the positive solution to the given equation. Again, keyword solution, I'm finding an x-intercept. So let's go ahead and graph what they give us. Negative 56 over x plus 15 equals x. So they want the positive solution. Well, if we look at our two solutions, they're going to be negative 7 and negative 8. So we would just say x equals negative 7 and negative 8. No positive solution. Number 6, an object is kicked from a platform. The equation h equals negative 4.9 t squared plus 8t plus 15 represents the situation where h, I'm going to highlight this, h is the height of the object above the ground in meters, t seconds after it was kicked. What was the height in meters from which the object was kicked? So really h is just y, so y is going to be the height in meters. Our t is really just the x, so x would just be the seconds. So we want to know the height when it was first kicked, so let's go ahead and graph that. Y equals negative 4.9 x squared plus 8x plus 15. And it looks like when it was first kicked, so right here, it was 15 meters off the ground. Okay, so when it was first kicked, it was 15 meters. Hi. Number 7, it gives us a function and it says the given equation defines the function f. For what value of x does f of x reach its minimum? So we're just looking for the minimum. And when we find the minimum, it just wants the x value of the point. So again, let's graph it. Y equals 2x squared minus 25x plus 63. The minimum is down here. 6.25 comma negative 15.125. So I'm going to write that down. And of course, it wants the x value, so my final answer would just be 6.25. That's the x value. Okay, number 8, I am going to factor, but first I need to go ahead and get this into standard form. So I'm going to distribute the 8x and the negative 3. So for the numerator, we're going to get 8x squared minus 32x minus 3x plus 12 over 2x minus 8. So we can go ahead and combine like terms. We get 8x squared minus 35x plus 12 over, and let's go ahead really quick and factor this. So I can divide both of those by a 2. When I divide them both by 2, we end up with x minus 4. So my new denominator is just 2 times x minus 4. And remember, in order to graph the numerator, we're going to start with x minus blank, x minus blank. And I'll just leave my denominator alone. And then in our blanks, we're going to go ahead and fill in the x-intercepts. So let's go ahead and do that. We have 8x squared minus 35x, and then plus 12. So one of them will be 4, so I'll go ahead and fill in a 4. One of them we get 0.375. Let's make that a fraction. So 3/8. Now I just got to slide this in front. So we end up with x minus 4 times 8x minus 3 over 2 times x minus 4. So our final answer is going to be B. This one wants to know how many solutions we have. So let's talk about x-intercepts again. So let's go ahead and graph this. 2x squared minus 7x plus 12 equals 0. Well, I'm not seeing anything here. I'm going to take away the equals 0 and just see what it looks like as a parabola. And oop, it's actually never going to cross the x-axis, so this would have none. And that is number 9. So number 10, I'm finding the roots. So let's go ahead and do that. Remember, those are just x-intercepts. Roots is an x-intercept, zeros are an x-intercept, and an x-intercept is also an x-intercept. Remember, if we get rational solutions, we can just graph them. If we end up with irrational solutions, we're going to have to use the quadratic formula. So let's try the first one. And normally the calculator rounds to about 5 decimal places. So if our decimals that they give us are less than 5, that means that it's rational because the decimal just ended after 3 decimal places. It's not going on forever. So the first one will have 2x squared minus 7x minus 13 equals negative 10. And these are rational. So it's going to be, actually, we can just keep these as decimals, that's fine. So it's going to be x equals, let me find them one more time, negative 0.386. And the other one is, I believe, 3.886, yes. Let's do number 11. So x squared minus 31 minus 2x equals negative 6 minus 3 x squared minus 2x. So we get negative 2.5 and 2.5. Those are rational, so we are done. And then our last one, 9x squared equals 4 plus 7x. And these are irrational, so we're going to need to go ahead and use quadratic formula. First step is to get this equal to 0 so we can find a, b, and c. So I'm going to go ahead and subtract 9x squared to the other side. It's positive, that's why I'm subtracting it. So now I have 0 equals negative 9x squared. I'm going to put the 7x first, and I'm going to put the 4 last. So now I know that my a value, and you're never ever taking the variable or the exponent that's attached to the variable. My a will be 9, my b will be a positive 7, and my c will be a positive 4. So a equals negative 9, b equals 7, and c equals 4. And we're going to plug this into x is equal to opposite b plus or minus the square root b squared minus 4ac all over 2a. Let's go ahead and do that. X is equal to opposite b plus or minus the square roots of b squared minus 4ac all over 2a. Now the only thing that we're going to plug into the calculator is what's under the radical. So not the radical, just what's underneath it. So I'm going to type this into Desmos. I'm going to rewrite everything else. So it's going to be negative 7 plus or minus the square root of whatever I get all over negative 18. So let's do that. We're going to get 193. Now remember, this is really two answers. So our two answers are negative 7 plus root 193 over negative 18 and negative 7 minus root 193 all over negative 18. And we are down to our last problem. Okay, I'm going to go ahead and graph this and then copy down some points. So y equals 3x minus 3 and x minus 4. So here are some points. We got a vertex here, x-intercept, sorry, that was a y-intercept, not a vertex up here. We have x-intercepts and we have our vertex. So I'm going to put those 4 points down. So 1, 0, 0, 12, 4, 0, and 2.5, negative 6.75. This is an x-intercept because y is 0, so it's this one. This is a y-intercept because x is 0, and this is a vertex. So I'm going to put those on my graph. So I know my x-intercepts are going to be 1 and 4. My y-intercept is 12. My vertex is a minimum at 2.5, negative 6.75. And my symmetry is x equals, and then the same x value as my vertex. And my zeros are, of course, my x-intercepts again. The domain is going left and right forever. So I know that's just going to be negative to positive infinity. My range, it does not go down forever. My range only goes down to, let's look. This is the lowest point. So it goes down there and then up here. Well, my lowest y value is actually at my vertex, so I can go ahead and use that y value there. And I'm going to include it because it's a point on the graph. So it's going to be negative 6.75. That's the furthest down it goes, and then the furthest up it goes is forever. Now this function starts by decreasing. So from the left side of the graph, negative infinity all the way until right here, my vertex. So for decreasing, I'm going to put negative infinity until, and remember, we're only using x values every time other than for range. So the x value of this is 2.5. Now at 2.5, I switch directions and I start increasing. And we never start increasing, so I'll show you what I mean by that right here. So from 2.5 going forever and ever and ever and ever to the right, we are always increasing. So 2.5 to infinity. Now remember, positive means above the x-axis, so I'll highlight that in blue. Negative is below, and again, we're using only x values left to right. So on the left side of my graph, at negative infinity over here, we are starting as positive. So we're going to write negative infinity. We stop being positive at 1 at that x-intercept, and we start being negative from 1 to 4. At 4, we become positive again, so we'll put our union, our u. And we don't stop being positive for the whole rest of the graph, reading left to right. Now remember, end behavior is always as x approaches positive infinity, y approaches blank. As x approaches negative infinity, y approaches blank. Now in both cases, whether x is approaching positive infinity, so the right side of this graph, or x is approaching negative infinity, the left side of this graph, our y's are going up. So we are always approaching positive infinity. And we are done.